different ways, all right? So you can see in a scenario the many different ways to take a sample and hopefully make a judge on which one is best, which one is worst, depending on what you need. All right, so write a few of these things down here with me, ladies and gentlemen. It will help you stay engaged. It will help you stay awake. I know that's a problem. I know I'm running on fumes right now. I'm tired. I just need to go to bed earlier, but I just can't do it. I just can't do it. Anybody else get super awake when it becomes at nighttime? Like all of a sudden it's like 10 o'clock and you're like, boom, I'm awake now. Whereas like at 6 o'clock you were half asleep. What the heck is that? It's like your body's screwing you over. It's like, man, now I'm only going to get 5 hours of sleep. Yeah, me too. All right, let's do this. All right, so the Michigan Stadium, I assume football stadium, also known as the Big House, seats over 100,000 fans for a football game. The University of Michigan Athletic Department wants to survey fans about concessions that are sold during games. So how good is the food? Tickets are most expensive for seats on the sidelines in orange. So these ones here. Then corner seats, the green ones. I guess that's kind of green. Is that green to you? It's more of a yellowish to my eyes, but I'm kind of colorblind. And the least expensive are the blue seats on the end. All right. So first we're going to do the easiest one. Describe how the athletic department could use a simple random sample to obtain a sample of roughly 500 respondents. Okay. So this is the sort of the easiest one, just picking at random. But you can't just say pick at random. You got to give me more than that. If you're describing a random sample, you got to say a little bit more. So in the video, I kind of laid out a 3-step process for you. Label, randomize, tell me how you're going to randomize, and then do the selection. Okay? So in order to do this, we first have to label all of the people, the population. So label. But thankfully, most stadiums already have this. The seats have numbers, right? So label all the seats from 1 to 100,000. All right, that puts everybody in some sort of order. It allows you to numerate them and find them. So then we have to randomize. So using our calculator, we will generate 500 random numbers. And use, now here's where I do want to put one sort of caveat, and you do need to do this. You have to say that you are ignoring repeats. It's very possible if we do this 500 times, we might get the same number twice. Although 1 to 100,000, that is a big population. Even 500, you probably wouldn't, but you do have to make a little statement there that we are ignoring repeats to choose individuals. All right, now we are actually going to select. Now, we're not actually going to do this because we don't have a way to, but you do need to be able to do this on your calculator, all right? Do a random number on your calculator. If you don't know how yet, because you haven't YouTubed it, you need to YouTube it sometime. How to find a random integer, okay? So for me, I have to go to my toolbox, to probability, to random. I want a random integer. And then whatever you got to type into your calculator, I'm going to go from 1 to 100,000. All right, it's pretty easy, but you do need to find that feature on your calculator. Now I would just hit enter 500 times. You ready for this, everybody? 4, 5. No. But, so the first person we would go to seat number 50,299. 50,299. We would ask that person, all right, what do you think of the concessions here? Do you like the food? How's that hot dog? Then we would go to seat 1,751. Ask that person, how do you like your hot dog? Cracker Jacks? Do they do Cracker Jacks at football? Or is that just baseball? Then to the 90,000th seat. Hopefully you can see the problem here. That would be extremely inefficient because we go, all right, 50,000 might be over here somewhere. But then 1,000 would be over here somewhere. We have to walk over there. Then 90,000 would be over here somewhere. And even if we had a list and did these in order, it would still be pretty difficult to walk our way through this entire stadium to find these individual seats out of a sea of 100,000 people. That would be awful. So you probably would not want to do a simple random sample in this case. Okay? So moving on. That one's no good. Well, it's good, but too difficult. All right, describe how the athletic department could use a stratified random sample. So yes, this is also abbreviated. Well, no, it's not abbreviated SRS because that would be confusing. So this is not an SRS. I tried to make a big deal about that in the video. To obtain a sample of 500. All right, so stratum. This is where you group people together. People that you think are similar. All right, similar groups. So we think about this problem. All right, what types of people do you think would have a similar opinion about the concessions? That's kind of what you have to figure out. Our context is concessions. What people here do you think might have similar opinions about the concessions? And then you group those people together. And our only real option here is by type of seat. All right, these people right here, the most expensive seats, we'll put as one stratum. The second one will be the corner people because they paid a little bit less, and the El Cheapos. The end zone will be our third stratum. Because does it sound reasonable that people who paid more for a ticket might have a different opinion about the food than the people who paid less? It could be reasonable, right? That's your high rollers up here, all right, they might have a different expectation than your low ballers over here. That seems reasonable, and because that seems reasonable, it's not a bad idea, all right? So, label. We will divide the fans into 3 strata. All right, so plural is strata, singular is stratum, because that makes sense. All right, we will divide the fans into 3 strata by, I might just say ticket price. Sideline, corner, and end zone. And pick. All right, so if we want 500 respondents, we have to divide those 500 respondents evenly between the sideline, corner, and end zone. Oh, that's not going to work very great, is it? 500 does not divide by 3, so we'll just get close. So 500 divided by 3 is 166.66667. We can't cut anybody into thirds. Don't try it. It's bad. It gets messy. So we'll go 167 and pick 167 random individuals from each with an SRS, a simple random sample. All right. So I don't know if I can actually do this one for you. So we labeled randomize. I kind of took care of that in the previous sentence a little bit, didn't I? But using our calculator, we will generate 167 random numbers I guess we have to do that 3 times, though, for each strata. Should that be plural, stratum, or singular stratum? I don't know. For each strata, and use them to pick our individuals. The most important sentence, though, is that first one. That kind of takes care of everything right there. You're dividing the fans into 3 strata by ticket price, and then picking a simple random sample for each. And to get 500 people, we need 167 random people from each strata. Now, this one I do want to say a bit more about. This is oftentimes a great idea to do, okay? This leads to the most accurate numbers. Why can't I move this? There we go. The most accurate, least variable numbers, all right? This is preferable I don't know if that word has 2 R's or not, because our results will have less variability. And that's the case because if we think ticket price is going to influence people's opinion about the concessions, well, we want to make sure we get an even amount of opinions from each of those types of people. Hopefully that kind of makes sense. If we think the high rollers and the low ballers are going to have different opinions, well, we want to sample them equally. And if we do sample them equally, then our results will have less variability. Whereas with a simple random sample, the first one, all right, it would be possible that of our 500 random people, we could have had more from the end zones than from the sidelines. Just by random chance of picking, we might have more from the end zones than from the sidelines. So if you sample each strata equally, your results will have less variability. I'm hoping we can actually get some real numbers on that when we do the river problem for homework. so you can actually see that happen. We'll make some dot plots, and hey, this dot plot is more spread out, and this dot plot is clustered more together. So hopefully. All right, next, cluster sampling. Cluster sampling. All right, to obtain a sample of 500 respondents. Now, the what do we call it? Stratified random sample is also sometimes difficult to do, and so another option is a cluster sample, which is oftentimes easier to do. It requires less travel, and so hopefully I can show you why it would take less travel in this case. All right, so describe how they could use a cluster sample to sample 500 people. Well, if I take a look at the stadium is already divided into clusters for me. The section numbers, all of these are clusters. All right. Now, they don't really have anything to, there's no real connection between them. Some of the clusters are similar, some of them are different. So what I could do is I'm just going to pick some clusters, randomly pick a couple of clusters there, and then I'm going to survey the entire cluster. All right, so I'm going to randomly pick the group and then survey the entire groups. That means I don't have to move as much. But here we got to do a little bit of math. How many clusters do I have to pick? All right, so there are 41 clusters. Am I going to not have enough clusters to do here? Where is my calculator? If I have 100,000 fans in 41 groups, each group is 2,439. Those groups are all too big. I only need 500 people. We got to make the numbers smaller here for this to make sense. Let's take each of these sections and let's say, oh, there's 44. Oh, there are 44. That's sadly not going to help me much. It's still going to be huge, isn't it? 100,000 divided by 44. It's still going to be too big, I think. Yeah, it's still massive. So let's say that each section, like section 42, is divided into, they go by letters, don't they? A, B, C, you have row A, row B, row C, row D. Let's say each one is divided into an A, B, C, D, all the way to Z. All right, so within 42, there are 26 rows. In 43, there are 26 rows. Each one has then 26 rows. So now I get to do 44 times 26. All right, 1,144. So now if I do the whole population divided by that 1,144, that means each row is going to have 87 people in it. And I'm going to choose some random rows to look at, okay? So how am I going to describe this? We got to label and describe this. So the stadium is divided into 44 sections, and each has 26 rows. I am kind of making that up, but I think it sounds reasonable. And so what we are going to do is we are going to pick some random rows. We will pick blank random rows as clusters and survey the entire row. Now, how many do I have to pick here? Well, if each row has 87 people in it, and I want 500, how many rows do I have to do? 500 divided by 87 is equal to, I have to pick, let's go 6 rows just to be safe. I'll round up there. So we will pick 6 random rows as clusters and then survey the entire row. Now, what are the benefits here? That's really easy. I only have to go to 6 rows now and ask those people. I don't have to trudge through the entire stadium looking for individual seats or anything. That will be much, much easier if I just go, hey, row B here. Could all of you fill this out real quick for me, please, 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 please? Give it to those 80 people. They fill it out. They give it back to you. Then you move on to the next row, wherever that might be in the stadium. It's much, much easier than doing random people from each section or random people from the entire stadium. All right, that's really difficult. The sad part is the cluster does not give you any benefits like the other one does, the stratified random sample. So I might make that a note. This is easier. But no benefits like the stratified. So if you can do a stratified, it's better because you get benefits of less variability, but oftentimes cluster is just so much easier. And so you'll just say, you can usually do much more clusters easier than stratified if you want less variable data. All right. I've been talking a lot. Time for me to take a break from talking. I want to see how you're doing on bias. So we're going to take a break. Well, break for me. I have one question on bias. I want to see how you can write those sentences. There are 2 criteria that you got to be able to tell me about bias. So I want to see if you can do that. So you're going to head on over to the general channel here. I'm going to add a tab. There it is. Just one question. Still about our stadium here. Head on over to the general channel. It should be there now. Can you describe for me the bias in my suggestion here?
First of all, I had a question.
Go for it.
So for the cluster, why did we choose 6 random rows? Like, what was the thought process by choosing 6 exact? Does that make sense?
Yeah, I got you. Yeah, so a little bit of math there. I wanted 500 people. All right. Why did that disappear? Freaking OneNote. Maybe if I minimize and bring it back. Nope. All right. So if I want 500 respondents, how many rows will give me 500 respondents? So I had to do a little bit of math there. So there are 100,000 people divided into the 44 sections. So each section has 2,272. But in those sections, that's too many. Each row, let's suppose the rows go from A all the way to Z. I am kind of making that up, not going to lie. All right. Let's say the rows go from A to Z. There's 26 letters in the alphabet, right? You're not saying no, so I'm going with it. So if there are 26 letters in the alphabet, I'm going to take that and divide it by 26 rows. That means there are 87 people in each row, roughly. So if there's 87 people in each row, how many rows do I now have to get and ask to get up to 500? So I did 500 divided by 87. And so it's more than 5 rows, so I chose 6 rows. That will definitely give me 500 people.
And when you're choosing these rows, like let's say we're actually doing this, like we're at a stadium, we're actually doing it, would it be like random throughout, or would it be like within a specific section?
It would be random throughout. So if I really want to be super precise here, I would have to say one more thing with labeling. Somehow, OneNote's going to screw me over. Somehow I would have to label all the rows. And so I could do a random number and be like, I need row blank. And so then I could go find row blank. I suppose one way you could achieve that is doing a random number twice. Roll a random number to see what section you're in. So random number 1 to 44. There. Probability. Random. Integer from 1 to 44. Whoa. All right, so I'm going to section 21. Now what row am I going to go to? So I do that again. But now I want to go from 1 to 26 because there's only 26 rows. So I'm in section 21. Whoa. Row 21, apparently. That was coincidence. And that's how you could then pick which rows you would do. And I would have to do that process 6 times to get my 6 rows. Does that make sense?
Yeah. And this is just all random as opposed to the other method, the stratified, right? And that's like where there's a methodology behind choosing, correct?
The first level has a methodology, yes. So at first you're like, hey, I think these groups are similar, so I'm going to group you this way.
Okay.
That's you just using logic. But then within it, then you use the random to pick the sample from each group. Yes. Now let me give you 5 more minutes to write your sentences because I was talking. All right, we got one more to do, ladies and gentlemen. One more to do. We got, 4 options done already? We have one more sampling method, the systematic random sample. All right, but why the heck did you math people keep using SRS as the acronym? Can't you think of a different word? No, we can't actually. Systematic random sample, not to be confused with the stratified random sample or the simple random sample. It's like we get an evil pleasure out of this or something. All right, so what this does is you randomly pick an individual in the first k number of individuals, then pick every kth individual after that. But what the heck does that mean? All right, I got to draw a picture here. Imagine we had all 100,000 people lined up in a line, okay? So we've got the first person, the second person, the third person. We got all 100,000 of them lined up in a line. And we want to, again, pick 500 people for our survey. Well, what we could do simply, let's see, what is that divided by that? Again, I've done this. 100,000 divided by 500. 200. So what I could do is I could pick every 200th person. Pick every 200th person. Just go down the line, and every 200th person, I would give them the survey. That would give me 500 people. It'd be fairly random. It would get people from the whole group spaced out nice and evenly. I could pick every 200th person. But the problem is where to start. All right, you can't always start at the beginning. All right? Because what if the person who got there first has a certain type of opinion? Okay, the people that get there early might have a certain opinion. I can't just go 1, 201, 401, 601, 801. I can't do that. So where to start, I have to randomly pick where to start. So what I'm going to do is I'm going to pick a random number from 1 to 100. Sorry, 1 to 200. I'm going to do a random number from 1 to 200. This is going to be my first person, somewhere between 1 and 200. So I'm going to do that here. Random 1 to 200. 19. All right, so I'm going to start with the 19th person. The next person I'm going to ask, I'm going to go down the line 200, and I'm going to ask the 219th person. And now I'm going to ask every 200th person after that. So I'm going to ask 219, I'm going to ask 419, I'm going to ask 619. And technically these are all random because the first one was random. That could have been a 5, it could have been a 87, it could have been anything from 1 to 200. These are all now randomly picked. And I'm going to do that all the way up to, what would the last one be? 999, or 99,919, I think, would be the last person. And that would give me 500 people. All right, that is the systematic random sample. Hopefully you can see why it's called systematic. I don't know, to me it seems systematic. You go in this case, every 200th person. So you do have to figure out a little bit of math here. Where the heck did Bolt get the 200 from? Why am I doing every 200th person? Because the total population was 100,000. And I wanted 500 people. All right, so 100,000 divided by 500 is 200. That means I have to pick every 200th person. So that number will change depending on your population and your sample size. Okay? So how do we describe that? Because you do need to be able to describe that process to me. Okay, draw. So to do a systematic random sample, we will randomly pick one person in the first 200 people. Then pick every 200th person after that. That will give us a sample of 500 people that is random. Now, in this case, I don't think that's any easier than the others because you still have to make your way through the whole stadium, right? You still have to make your way through the whole stadium. That would be pretty difficult. You probably wouldn't want to choose this method. But sometimes this is easier to do, to actually pick out a sample, is to do it systematically, randomly picking your first one, and then picking every kth individual. So because that 200 changes, the definition uses the letter K. All right. So you pick a random person. The kth individual is your first one, and then pick every kth person after that. All right, that's the new one there. Does that kind of make sense? I didn't think that one was quite as difficult as the stratified, but anything you want me to elaborate on more there? All right, good deal. Good deal. All right, ladies and gentlemen, I think we're going to call that a day. This next thing would take longer than we have to talk about, so we might try to hit that later. Let's call that good. You do have enough information to work on those homework problems. If you want to start that now, you can. The video is not made yet, so I will have that up probably by like 3 o'clock this afternoon, I would say. It's almost done. I've got it formatted and stuff, but I got to upload it and do a few things. So that one will be up by like 3 o'clock for you to watch the video. All right. And one more plug for Saturday morning. Come say hi. All right, don't make me get up early for nothing. It's going to be fun. It's going to be good. It's going to be tasty. And you're going to get free stuff, apparently. So come on by Saturday morning, 6:30 to 8 or 8:30?
8:30.
8:30. All right, but by then the food's going to be cold, so you want to come earlier. All right? And I'll have coughed on it a bunch, so you don't want that one. You want the earlier one. I'm just saying. All right, everybody. You have a great day. I will see you Saturday or Monday at the latest. Have a good one.
Bye, Mr. Bolt.
Bye.